Hello coders, in today's tutorial I'm going to be teaching you continual integration and continual deployment using GitHub Actions and a Laravel application. We're going to be deploying our application to a Cloudways VPS server. But before we do that, we need to ensure that the code that we write adheres to certain standards and is tested. This is where continual integration comes in. We're going to install PHP Stan and use PHP Unit. The Laravel application that we're going to use is a book API, and you can get this through the GitHub link in the description down below. The first thing we need to do to this application is install PHP Stan. PHP Stan is a static analysis tool. To install PHP Stan, open up the terminal, type composer require PHP Stan /PHP Stan. And we're doing this in development mode. So put in the argument --dev. We also need to install Larastan as well and install that in development mode like before. Once those have been installed, we need to configure PHP Stan. Type touch phpstan.neon. This is the PHP Stan configuration file. Once we've created that file, open that up. We want to ensure that PHP Stan runs with the Larastan extension. We can do that by typing vendor larastan extension.neon within the include section of the phpstan.neon configuration file. After this, we can start supplying some parameters to PHP Stan, namely the paths. This is the path in which we want to analyze, and we want to pass in the path of app. This is going to analyze all of the files in our app directory. We can also pass the strictness level that PHP Stan is going to use to analyze our code base. In this example, I'm going to set it to 5, but there are many other levels that you can use. Once we've saved the PHP Stan configuration, we can run PHP Stan against our code base. And we do this by typing vendor bin PHP Stan and passing in the command analyze. Press enter and you'll see that it's using the PHP Stan.neon configuration, and we ran it with no errors. That's fantastic. Laravel comes with PHP Unit. You can see the configuration in PHP unit.xml here. Laravel also comes with its own unit tests. So we have a feature test and we've got a unit test here. If we type vendor bin PHP Unit in the command line and press enter, we're going to run those unit tests. And we can see that 2 tests have passed. We now have PHP Unit and PHP Stan running against our code base. Of course, we have to run these commands manually. In the next part of this tutorial, I'm going to be showing you how to create a GitHub action to test the integration of our code when we commit it to GitHub. The first thing we need to do is create a .github directory within the root of our project. Within that folder, I'm going to create another folder called workflows. And within the workflows folder, I'm going to create a YAML file called main. We need to give our workflow a name. The name I'm going to call this is build, test, and deploy. After we've added the name of our workflow, we need to define how our workflow is going to be triggered. And we do that by typing on, and then on the next line, we type push. And then on the next line, we add branches. And this could be an array of various different branches. In this case, we just have the main branch. Before I go any further, let's just recap. So we have the name of our workflow, and then we have our trigger. So we're saying on a push against the branch main, we're then going to fire off our GitHub actions. And these GitHub actions are defined as jobs. So under here, we want to add jobs. The job that we want to create is build. We need to define what operating system this job is going to run on. Type run -on, and then we give it the operating system. So this is Ubuntu latest, and of course you could change this if you wanted to. And then we define the steps that this job needs to take. The first step will check out the code. And each step has a name and how it's used. So in this case, we're going to use the checkout action that has already been defined that will check out the code. And this at v4 means that we're running on version 4 of this checkout action. After we've checked out the code, we then need to use PHP. So the next step will be to set up PHP. And we set up PHP using this action here, and we can pass in this argument, so it's using PHP version 8.3. Now, when you create a Laravel application, it doesn't come with a database. And so when we build this application in the cloud using GitHub, we're going to need to create a database. And so this is where we start creating commands that run in these actions. So let's create a database file within the database folder. Before I go any further, I want to just discuss environment variables, because please be aware that you are pushing your application to a different environment and you're building it on a different environment. You could define GitHub as a test environment or a staging environment or a environment before you go to deploy it. But just know that it's not your local environment. And your local environment is going to have a lot of hidden files, such as your environment variable file, your .env file. So what we need to do within our GitHub actions is create an environment variable file for GitHub to use. In this example, what I'm going to do is copy the .env.example file and create a new file called .env.test. This is going to be used for GitHub. And an environment variable that we must include is the app_key. Now, this is going to be different for each environment. Create your key and save that file. Before we go back to our workflows, I just want to demonstrate that if we go to our gitignore file here, these are all the files that get ignored. These aren't going to be shown on GitHub unless they get created via the jobs. We're not going to have a .env file or a backup or a production or anything like that. So this is why we've created our .env.test. However, something that you must be aware of, do not put anything in this that is sensitive. If you're doing something that is sensitive, use GitHub environment variables that you store against the repository, and then you can populate this as the application gets built. Back to our workflow file. Underneath the database creation step, we can copy the .env file. We've created the env.test file specifically for GitHub, and what we're doing is we're copying that file and we're passing that in to .env. At this point, you may want to be populating the .env file with environment variables that you have defined against the GitHub repository. Once all of that setup is complete, we can now create the application using Composer. So the next step will be to run Composer install. As I've mentioned before, we have a fresh database, which means that we must run any migrations. And we can do that in a step where we run php artisan migrate. The next step is to run php stan like we did when we ran it locally. We're going to do vendor bin php stan analyze. And after php stan, we're going to run php unit. So that's vendor bin php unit, like we've done locally. But of course, this is all running against the Ubuntu operating system that we are creating when we check out. Let's recap this workflow file. We have a name for this workflow, and that is to build, test, and deploy. We have a trigger here where we're saying on a push against the branch main. That needs to be branches, like so. And this trigger will create a series of jobs. The first job here is the build job. Now, each job runs against an operating system. This should be runs on Ubuntu latest. After this, we define the steps within the job. The first step is to check out the code. After that, we set up PHP using PHP version 8.3. The next step after that is to touch a file. That file is going to be our database file. Once that's done, we copy over the .env.test environment file that we created earlier over to the .env file. We've now set up the environment, so now we can install our application. And we do that in this step where we run Composer install. After that, we run the data migrations using php artisan migrate. migrate. At this stage, we've built our application and now we can test it. We do so using PHP Stan and PHP Unit. We now have a GitHub workflow that builds and tests the application. This means that we now have continual integration because every time a commit is made to the main branch, we run these steps. And if any of these steps fail, then we can no longer deploy our application. Before we get to actually deploying our application automatically using GitHub Actions, let's first commit this change and make sure our GitHub Actions work as we expect. In Visual Studio Code, I'm going to open up the terminal and type git status. This is going to show me what code has changed. I'm then going to type git add, and this is going to add the GitHub Actions and the .env.test file. And we're going to do a git commit with the message updating actions. I'm then going to push these changes. Let's go to GitHub and make sure that these changes are actually running. In the browser, we can see that this is the latest commit. If we open this up and then click on details, we should see the build and all of these steps. And these are the steps that this build job has taken. We checked out the code, we set up PHP, we created the database, we copied the env file, we installed the application, we ran PHP Stan and PHP Unit, and then we completed the job. And if we opened up the PHP Unit task, we can see that 2 tests have ran, 2 assertions, and everything is fine. If we opened up PHP Stan here, we can see that there has been no errors. If any of these jobs fail, then we can no longer continue in our continual integration pipeline. Before we create our application and deploy it via GitHub Actions, we must first configure the VPS, and we're going to do that in Cloudways, and this is what I'm going to be demonstrating next. If we click onto the servers list here, we can see that there is one server called Demo1. This server is built on AWS. If we click into the Applications tab, we can see that there is an application called Demo with the project of book-app. If we click into the application and go to Application Settings, we can see that we have the folder name and the web root set here. We need to make some adjustments to this project, the first being the web root folder. If we click on the edit button here and change the public_HTML directory to be public_HTML/public. Click the save button and wait for that to change. Once the web root has changed, head over to the demo server. Click on the settings and packages. Now click into the packages tab. Make sure that the PHP version is set to 8.3. If it isn't set to 8.3, click on the modify button and choose PHP 8.3 from the list provided. Once that has been set, we need to configure Git on the VPS. To do that, we SSH into the VPS and we run some commands to configure the settings of Git. To get the SSH credentials, head over to the master credentials section in the server. To SSH into the VPS, we need to provide the username and the public IP as the host to the SSH with the credentials given on the Cloudways website. In the terminal, type your SSH credentials. When you press enter, it's going to ask you for the password. Once you provided the password, you're now into the VPS. The first thing we need to do is remove the index.php file in the public_HTML folder. To do that, access the applications folder and then the application itself. Within the applications folder, there is a public_HTML folder. We want to remove the index.php file. To do that, type rm and then index.php. To configure Git, the first thing we need to do is set the settings for how Git pulls the code down. We're going to use pull.rebase false. So type git config pull.rebase and then false. The last setting that we need to supply to Git is to tell Git that the current working directory is safe. To do that, type pwd to get the current working directory and then type git config --global --add safe directory and then paste in the directory that was output in the previous command. It's important to note that before cloning the GitHub repository, we must first provide GitHub with a deployment key, which is our SSH key on the VPS. I've demonstrated how to do this in the previous tutorial within this series. I'll leave a link to the tutorial in the show notes below, as well as in the tutorial on the howtocodewell.net website. We should now be able to clone our GitHub repository. However, please be aware that the address of this GitHub repository may be different to yours, because hopefully you've cloned the repository and therefore it's under your GitHub account. To clone the repository, type git clone and then git@github.com : your GitHub account name / and then the repository. Make sure that we have a period at the end, because this means that we're going to clone the repository in the current working directory, which is public_HTML. Once that's done, we now have all of the files on the VPS. Now that the VPS has been configured, we can set up the SSH keys to allow GitHub to deploy the application. This is the continual delivery part of this tutorial, and that is what I'm going to be demonstrating next. Go back into the terminal, because now we need to create our own SSH keys. To do this, type SSH keygen -t RSA -b 4096 -m PEM, all uppercase, and then we're going to supply a comment which is cloudways -deploy, and we do that with the -C argument. After that, we're going to supply the -f argument. Now that is the location in which these keys live, and my location is going to be .sh /RSA_cloudways. This could be totally different to how you want to set up your keys. Once you've done that, press enter, and then it's going to generate a public and private key pair. Now, I've already done this, so what I'm going to do is overwrite these keys. So I'm going to press Y, and then I'm just going to press enter for an empty passphrase. I'm going to press enter again because I need to confirm that there's going to be an empty passphrase. And now we can see that we've got these two files that have been generated. The one ending in .pub is our public key. The one that doesn't end in .pub is our private key. Now we need to supply the private key to GitHub, and we need to update the authorized keys on our VPS to allow our public key. Head over to GitHub and then click on Settings within your repository. Scroll all the way to the bottom here and click on Secrets and Variables. Then click on the Actions button. I've already got my SSH keys set up here, but what I'll do is I'll demonstrate how to create a fresh one. Click on New Repository Secret. You want to supply the environment variable name and then the secret. After you've done that, click Add Secret. We need to supply the username, the private key that we've just seen, the host, as well as the app path. If you can't use the SSH keys, you could try using the SSH password that's given to us in the Cloudways website. The app path is the path to the working directory that we just had. It's the output of the pwd command. As I mentioned earlier, we need to update the VPS to allow this SSH key to be used. We do that by updating the authorized keys within the SSH folder. But there is an easier way to do that than just SCPing that up and then manually changing the file. We can use the command sh-copy-id, and there's a lot of arguments that we can supply to this command. The argument though that we need is the -i argument. That is the path to the identity file. This is the key that we've just created, which is in our .sh/id_RSA_cloudways file. We need to supply the SSH credentials, which is the username and then at the host name. Once you press enter, it will update those authorized keys on the VPS. The last step that we need to do is update our GitHub Actions workflow to deploy to the VPS using those environment variables that we've just supplied to GitHub. If we go back to the main.yaml file and scroll right to the bottom here, we create a step within our build job. The step has the name deploy using SSH. We're going to use the action from appleboy/SSH-actions. I'm going to use the version of 1.1.0, although this may change in future. We're going to supply this with a series of variables. The first one is the host. And to access the secrets on GitHub, we supply this variable holder with the value of secrets.ssh host. This is the environment variable name that we've created in GitHub. We also need to supply the username, and we either supply the key that we've generated or we could use the password. This is going to generate an SSH tunnel using those credentials. We can now supply a script to run inside that tunnel. Once the SSH tunnel has been established, we then run a command. And that command is to change the working directory to the directory that's stored in secrets.apppath, and then run the command build.sh. This is the build script that we created in the previous tutorial. This build script is going to pull all the changes from GitHub. It's then going to create the database if it doesn't exist. It's then going to run composer install to run any package installations. It's then going to run artisan API-platform to install the API platform assets. It's then going to migrate the database using PHP artisan migrate, and then the app is built. You can find this build script and the whole code in the GitHub repository, as well as in the write-up for this tutorial. Let's make a change to this build script to ensure that the CI/CD pipeline is working correctly. What I'm going to do is change this output where it says the app has been built to the app has been built and deployed. Let's run git diff to ensure that those changes have been made, and then run git add and then build.sh. And then I'm going to type git commit -m and then updating build script. We're going to run git push, and that's going to push the changes to GitHub. Let's head over to GitHub now. If we clicked on the build job, we should be able to see that it's starting. It's checking out the code. It should then create the database, install all the composer packages. This is running obviously on GitHub. And then it's running the migrations, running PHP stan, and then it's deploying using SSH. So we can see that on the VPS, we're pulling from GitHub, creating the database if one's not found, installing any composer packages, and then down here, we can see our new output. The app has been built and deployed. And that is how we can use continual integration and continual delivery to build, test, and deploy our Laravel API. You can find a full write-up of this tutorial as well as the code in the show notes below. Thanks ever so much for watching. Happy coding. See you again next time. Cheers. Bye.